solve the following inequality for x, and we've got an expression here that's actually a cubic. Now for all cubic inequalities, and this actually applies to all polynomial inequalities in general, from quadratics to quartics to anything of higher order, the way we would solve an inequality is you first rearrange to get 0 on one side of the inequality. So in this case, we've already got 0 there, so that step's taken care of. Step 2, and this is an important step, we need to actually sketch the polynomial using our understanding of how cubics work, or for higher order polynomials, how those ones work. We've got to actually draw the sketch. Once the sketch is drawn, we can inspect the graph and solve the inequality visually. So if the question is saying, well, where is this less than 0, then we just have to look at our sketch. So for example, we would look at this sketch here, and we would pick all the sections where it's less than 0 on the y-axis. So for example, we would pick this part and this part as being less than 0, and we would just write our solution using set notation. So let's go through an example of this. To begin, we will solve this for our x-axis intercepts to help us sketch. So let's, for example, give the polynomial a name to make it a bit easier to work with. So I've just called the polynomial side of it p. And let's just say we're going to solve for the x-intercepts, so we're going to say let p of x equal to 0. So we're going to solve for the x-intercepts using the null factor law. Right, now equating each of these brackets to 0, we end up with x is equal to minus 1. This one, we end up with x is equal to 1/3. And this one is just x is equal to 2. These are our x-intercepts, so let's go ahead and try to draw them on some axes. We have a minus 1 here. We have a 1/3, which is very close to the 0, and we have 2, which might be over here. Awesome. Now, importantly, we have to make sure we get the direction correct. So is it going this way or is it going this way? That's really important because it will completely change our answer for the inequality. Because if it goes this way, if it goes like this, the sections that are above are here and here, whereas if it goes like this, the sections that are above are here, are the opposite ones, here and here. So that's why we really need to be careful with this step. So you might want to use a sign diagram, or you can find one other point that might help you. So in this situation, we can find the y-intercept, and that will help us because we'll be able to tell if it's positive or negative in this section, and we know for a cubic it must follow the rest of the shape after that. So let's let x equal to 0. So we do p of 0 equals, so we have 0 plus 1 is 1. We have 3 times 0 minus 1, that's minus 1. And we have 2 minus 0, which is 2. So our answer is minus 2. That gives us the y-intercept, 0 minus 2, which might be here. 0 minus 2. And that tells me that between these two axis intercepts, my curve will be going down and probably around like that, which tells me that I can now complete the rest of the curve by following the shape of a polynomial that has to go through all those points. Okay, so now we've got a sketch of the cubic. We'll call this p of x. And now the question is saying, where is p of x? So remember, this is p of x. Where is that larger than 0? Make sure you get the correct direction of the sign. So compared to p of x, we're saying that this side is larger than 0. To do that, all you have to do is have a look at the graph and pick only the sections where y, which corresponds to p of x, where is that larger than 0? And that's anything that's found in the positive side of above the x-axis. So if you have a look, I can see that this section is above 0 and this section is above 0. Those are the two sections that we're going to be looking at, and we just have to give a way of representing them, and that's where set notation comes in. We will say that the inequality, we're solving it for x, so we have to say x is, and we give this element of symbol, and then we have to list the sections where x applies to these positive bits. So for the left, this very bottom one, we're looking at For this bottom one, we're looking at the section of the x-axis that's from here all the way to negative infinity. Do you agree? Can you see how for all of the coordinates on this positive part of the line, we have to look at x values that are below the -1? So this section will be from negative infinity to -1. And the question is larger than, not equal to, so we don't include the -1 because it doesn't, at -1 we are on y equals to 0, whereas we're only looking at where we're larger than y equals to 0, so we're only larger, not including the actual intercept. Okay, let's do the next section. So that's this section here. So the x values that correspond to this positive bit in the y are between these two x-intercepts. So we'll put union to show that there's another section that we're including, and we're going from 1/3 to 2. So we're looking at this number line between these two x-intercepts, which is 1/3 to 2. Okay, and this is our solution for the inequality. What it's saying is, if you put any x values within this set into the polynomial, the answer will always be larger than 0. And that's because for the polynomial, those sections are above 0. So that makes sense from a logical perspective as well.